Welcome back, guys. So real life applications of inequality. Please, if you are new to this channel, remember to click the like button below and the subscription button. God bless you. Yeah, so real life applications of inequality. Example number 1: a young adult may be defined as someone older than 21 but less than 30 years of age. Okay, express this statement using inequality. A young adult may be described as someone that is greater than 30, older than 21, or but less than 30 years of age. So express this inequality using express the statement using inequality. Or if you are solving word problem, the first thing is to translate their sentences into algebraic expressions, and then you put your signs, inequality signs in this case, and then you write your statement. So in this case, we don't have anything to solve. We only have to change this statement into an algebraic statement. Okay, so let the young adult equals to x. Then the definition says someone older than 21, that is x is greater than 21. Okay, and you know that this can be written as 21 less than x. Okay, but less than 30, so x is also less than 30. Okay, so let's call this one equality 2. So express the statement using inequalities. So the statement can be written as 21 less than x less than 30. Combining 1 and 2 will have the statement. So this is the inequality statement representing the given description of the age of a young man, and that solves the problem. Example number 2: middle-aged may be defined as being 40 or more and less than 60. Okay, so we say let middle-aged person equals to y. So then y may be defined as being 40 or more, that is y is greater than or equal to 40 or more. That equal to means equals to 40, greater than means or more than 40. Okay, so this can be written as y 40 is less than or equals to y. Let's call this equation 1. Or less than 60, so y is strictly less than 60 here. Okay, so call this equation 2. So combining equation 1 and 2, that's combined inequality. Combining 1 and 2, we have 40 less than or equals to y less than 60 as the expression, and that solves the problem. Example 3. So example 3 is a kind of more complex case. Look at the question. Life expectancy is the name of the question. Okay, it's a real life application. The Social Security Administration determined that an average 30-year-old male in 2014 could expect to live at least 51.9 more years, and that an average 30-year-old female in 2014 could expect to live at least 55.6 more years. Okay, look at the word more here. More here. So both expressions are expressed greater than or equal to expression. So A, to what age could an average 30-year-old male expect to live? Express your answer as an inequality. B, to what age could an average 30-year-old female expect to live? Express your answer as an inequality. Who can expect to live longer, a male or a female, and by how many years? So let us answer the question one after the other. What we are answering is 3. Okay, so transforming what we have into statement, Okay, so let the 30-year-old man equals to S. Let the 30-year-old man equals to X in this case. All right, so from the statement we have 51.9 years or more. So X is greater than or equals to 51.9 from the question. Okay, then for 30-year-old female, 30-year-old female, okay, let it be equals to Y. So according to the statement, Y is greater than or equal to 55.6. okay, so these are the inequality. Now answering the question, back to the question. So to what age could an average 30-year-old male expect to live? Express your answer as an inequality. So for average 30-year, an average 30-year-old man, okay, so for X we have 30 is 30-year-old already, so we do 30 plus 51.9. okay, so X should be greater than or equal to 30 plus 51.9. So that means X is greater than or equal to 81.9. So an average 30-year-old man will live 81.9 years old in 2014. And for the female, for Y, we do Y greater than or equals to 30 plus 55.6. okay, so Y is greater than or equal to 85.6. so in 2014, so that is the inequality for an average 30-year-old female. Okay, and that answers question A and B. For C, who can expect to live longer, a male or a female, and by how many years? So answering this question, from here you can see that female is 85.6 and male is 81.9. so female will live longer. So female will live longer than male, and the difference between the age is 85.6 minus 81.9, and that is 16 minus 9, which is 7. 4 minus 1, we have 3. So if we subtract, we have 3. So the difference between the age gap is 3.7 years. So female, average 30-year-old female will live 3.7 years or more than an average 30-year-old male, and that answers the question. Another example, this example is applicable in general chemistry. Okay, so for a certain ideal gas, the volume in cubic centimeters equals 20 times the temperature T in degrees Celsius. If the temperature varies from 80 degrees to 120 degrees centigrade or Celsius inclusive, what is the corresponding range of the volume of the gas? So let us transform this statement into algebra. Okay, so first let volume equals to V, volume equals to V in cm cube. Okay, and let the temperature equals to T in degree Celsius. Okay, so now from the statement we have that volume equals to 20 times temperature. Okay, volume equals to 20 times temperature from the first sentence. Okay, that is what we have there. Then from the second statement we have 80 degrees Celsius less than or equal to T less than or equals to 120 degrees Celsius. Okay, from the second statement the temperature varies between 80 and 120 inclusive. So because of this inclusive, we have to put equal to there. So and then we have the statement. So calculate the corresponding range of the volume. So the volume is going to be, let's say we have V1 equals to 20 times 80, okay, 20 times 80, which is a 1600 centimeter cube, okay, and V2 equal to 20 times 120, which is 2400 centimeter cube, okay. Believe you are following. So hence the corresponding temperature or the corresponding volume for this temperature will be writing it the way we write it, V1 less than or equals to V less than or equals to V2, okay, and V1 is 1600 centimeter cube less than or equals to V less than or equal to 2400 centimeter cube, and that gives the corresponding volume. So another way of doing that is to multiply all through by 20, and then we have the answer. So consider the next example, which is a real estate. Okay, so we can see that inequality is very important. Yeah, it has so many applications even in real estate. All right, so a real estate agent agrees to sell an apartment complex according to the following commission schedule: $45,000 plus $25,000 of the selling price in excess of $900,000. Now, assuming that the complex will sell at some price between $900,000 and $1.1 million, this $1,100,000 inclusive. A. Over what range does the agent's commission vary, and how does the commission vary as a percent of the selling price? So let us see how we can calculate this. So let the agent's commission equal to X. First, let the agent's commission equals to X, okay. Then the selling price, let the selling price equal to Y. Okay. Now the commission can be calculated as follows. So the commission for X, we have on X we have 45,000. So for the calculating commission now, X equal to 45,000 plus 25 over 100 multiplied by 900,000 over 1. Okay, so 45,000, the commission was 45,000 plus 25% of the selling price. So we do 45,000 plus 25 over 100 times the selling price, and that is what we have here. So this cancels this, and by the time we multiply that out, what we have is what we are going to have there is 45,000, okay, plus $225,000. So if we add that together, we have $270,000. So therefore X equals to $270,000. That is the commission, the first one. So that is X1, guy. That is the first commission. Now the second commission. Okay, assuming that the complex sell at some price between 900,000 and this inclusive, so we calculate the second commission of $1,100,000. So second commission, let's call it X2, equals to 45,000 plus 25 over 100 multiplied by 1,000 or 1 million $100 over 1, and if 20 cancel 20 here, and if we multiply those ones out, we have 45,000 plus what we have there is 275,000. okay, and that will give us, guys, $320,000. $320,000. So that is x2. okay, second commission. Now the original commission, okay, so the original commission, so answering question A, over what range does the agent commission vary? So the range of the commission is given as x1 less than or equals to x less than or equals to s2, and that can be written as first commission 270,000 less than or equals to x less than or equals to $320,000. so this is the range of the commission, and that answers the question, guys. So for question B, these are the range of the commission. Question B, how does the commission vary as a percent of the selling price? How does the commission vary as a percentage of the selling price? So we take the first commission over 900,000 times 100%. okay. Yep. So that is what we are going to do here. So calculating how the commission changes, so let's say commission over selling price times 100% equals to commission percent. okay, so let's call it C percent. So for x1, which is x1 is $270,000, so we do x1 over selling price multiply by 100 over 1, and that will give us $270,000 over $900,000 multiplied by 100 over 1. This cancel this, guys, this cancel this, so we have this and 9 here. Now here we have 3, so this is just 30%. okay, so x1 is 30% of the selling price. Now the second commission, x2 over sp times 100 over 1 equal to the second commission is 320,000 over 1,100,000 times 100 over 1. So this cancel this, guys, this 30 cancel this 3 zeros, and that will give us 320 over 11. So this is 320 over 11. So 11 in 32 is 2. 11 times 2 is 22. So 8 plus 2, so that is 10. 11 in 100, we have 9. 11 times 9 is 99, we have 10. So that will be 0 in 100, we have 9. So approximately this is 29.1%. So the change of the commission, or percentage change of the commission with respect to the selling price is can be written in form of this. So these are the percentage changes, okay, and that gives us the answer, yes, and that answers the question. So how does the commission vary as a percentage of the selling price? So we can see how the commission varies here. So as the selling price increases, the commission decreases. So commission decreases, okay, as the selling price increases, okay, vice versa. And that answers the question, guys. So let's look at the second example. The second example is applicable application of inequality to grade computation. Okay, so you can say that inequality is also applicable in grade computing. Okay, when you are computing grade or any computation at all. So the question says, in your economics 101 class, you have scores of 68, 82, 87, and 89 on the first 5 tests. To get a grade of B, the average of the first 5 test score must be greater than or equal to 80 and less than 90, strictly less than 90. To solve an inequality to find the least score you can get on the last test and still earn a B. Now, so this is what we are going to do. So we have 1, 2, 3, 4. So we have the first 4 tests. Okay, so first 4 tests equals to 68, 82, 87, 89. Okay, first 4 tests. So the fifth score, your fifth score, let it be equals to X. So okay, then now we take the average. So taking the average, we have a 68 plus 82 plus 87 plus 89 plus X, everything over 5. Okay, according to the question, is greater than or equal to 80. Okay, so let's do for 80 before we do for 90. Greater than or equal to 80. So this implies that 326 plus X over 5 is greater than or equal to 80. So this will give us 326 plus X greater than 80 times 5. Okay, multiplying all through by 80. So the sum of the first 4 tests is 326. Okay, that will give us that. So we have 326 greater than or equal to 226 plus S greater than or equal to 80 times 5, which is 400. So subtracting 36 from both sides, subtract 326 from both sides, so that will give us X is greater than or equal to 74. Okay, which can also be written as 74 less than or equal to X, and that answers the question. So alright, that is the first answer there. So hence the least score to earn a B, the least score to earn a B is a 74. Okay, solve an inequality to find the least score you can get on the last test and still earn a B. So the least score is 74. So therefore okay, so that is the question there. Alright, that answers the question, and then we are done with what we have there. Okay, so next question is exercising. Okay, how can we apply inequality in exercising? Look at the question there. Look at the question. Say, Sue wants to lose weight. For healthy weight loss, the American College of Sports Medicine (ACSM) recommends 200 to 300 minutes of exercise per week. For the first 6 days of the week, Sue exercise 40, 45, 0, 50, 25, and 35 minutes for the first 5 days. 6 days of the week. How long should Sue exercise on the 7th day in order to stay within the ACSM guidelines? So we take the average. So let the minutes of exercise for the 7th day. So let the duration or the minutes of exercise for the 7th day equal to X. Okay, so taking the average we have um, um, the average that we have 40 plus 45, okay, plus 0 plus 50 plus 25 plus 35 plus x, everything over 7 must be greater than or equal to 200, okay, because it has to be between 200 to 300 minutes to meet the ACSM guidelines. So we say greater than or equal to 200, okay. So adding everything together, we have 195 plus x over 7 greater than or equal to 200, okay. So solving that inequality, we have 195 plus x greater than or equal to 200 times 7. So we have 195 plus x greater than or equal to 1400, okay. So subtracting 195 from both sides, minus 195, so that will give us x greater than or equal to okay, yeah, so I don't think we need to divide, okay, we don't have to divide by 7, so we are not dividing by 7, sorry for that. So remember the first 6 days for 80 American college sport recommend 200 to 300 minutes of exercise per week. So if we add everything together, our sum must be greater than or equal to 200, so not the average, so not the average. So we just do we are not multiplying by 200, yeah, so this is what we have over there. So is 200, so if we subtract 195 from both sides, we have 5. So therefore Sue has to exercise 5 minutes on day 7 to meet the ACSM guideline. Okay, so I'm going to go over that again. So we say let the minute of exercise for the 7th day equals to x. Then according to ACSM, the sum of all the minutes for all the 7 days must be greater than or equal to 200. So we add everything together equals to 200, and then we'll find x. So that is 195 plus x greater than or equal to 200, and subtracting 195 from both sides leaves us with x greater than or equal to 5. So the number of minutes that Sue must exercise on the 7th day in order to meet the ACSM guidelines is 5 minutes. And that answered the questions, guys, and this is how to apply inequality to problem solving. There are still many more applications, so consult the literature and solve more. Remember to hit the subscription button and like this channel. Bye, see you in the next video.